At this point in time, we have our routes declared in a routes object like this. Now, what we need to do at this point is to write a function that traverses this object and registers the routes using the standard router.get or router.post methods that the ExpressRouter provides. Once again, let me reiterate that you don't have to do all this if you don't want to, and you can just continue to declare routes using the standard router.get for this project. Having said that, this technique here is what I prefer for my projects. The routes object here is a more readable structure in my opinion. Alright, now our function needs to work as follows. First up, it should be able to traverse this structure. So its first stop would be the top level keys get and post. At this stage, let's say our function is looking into the contents of the key called get. To continue forward, our function should confirm a few things. First up, the contents of the get key, for instance, needs to be an object. We are declaring multiple routes and their handlers inside an object. So this is our first requirement. Equally important is the fact that the contents should not return a null. That is, we need to have something in place for our function to register. Lastly, the contents should not be an array. The reason for this is quite simple. Our routes are declared as key value pairs, where the key is the route and the value is the route handler function. In JavaScript, you can programmatically deduce whether a given element is an object or a function. But both arrays and objects are categorized as objects. So we need a mechanism to ensure that specifically arrays are ignored. Arrays should be allowed when declaring route handlers, since we can use more than one route handler functions as you saw before. So this is the top level check that we wish to perform. Once this is validated, the control should jump to the individual key value pairs within the get or the post objects. By now, based on the object that we are traversing, we already know the HTTP method, that is get or post, and we also know the route and the route handler. So all we need to do is register the route. So continuing on from where we were at last time, let's write a function now called register routes, which accepts two arguments, a reference to the object being traversed and a reference to the HTTP method. Don't worry if this sounds confusing. I'll explain this in detail. Now, for iterating through our routes object, we will use a for in loop like so. As a conceptual aside, the for in loop works great with objects such as our routes object here. But avoid using it with arrays, because with arrays you need the order of elements to be in the same sequence as the structure of the array, something which the for in loop cannot guarantee. For arrays, there are better ways, and we'll see some of them real soon in this project. Okay, now that we are looping over the routes object, the variable key here will provide the access to the get or post verbs. So using an if statement, we'll first use the type of keyword and the value of the key being iterated upon by accessing the routes object with the key as the index to check if it is of the type object or not. The type of keyword returns the string object if the value of the routes with the index key is an object. Once we confirm that it is indeed an object, we will also confirm that it is not a null. We don't want to be traversing over invalid objects, so this check is a must. Finally, we need a way to check if the structure is not an array, since the type of keyword when used on an array also returns the value object, since arrays are also objects. This will be achieved like so. The instance of operator returns a true if the element being checked is an instance of the type array. By putting this statement in a bracket and using an exclamation sign, we are basically saying that the value of the routes object within the given key is not an array. When all of these three conditions are satisfied, we are ready to move our control from the topmost get and post keys to their individual objects and the route handlers. For this purpose, we'll recursively invoke the same function like so. Only this time, we'll pass in the contents of the top level keys as the first argument, that is the object containing all our route handlers, and we'll also pass in the value of the key variable, which will return either get or post. So once again, when this function runs for the first time, we will pass in the routes object. The for in loop will then traverse the object where the first element would be the get key. At this stage, our if statement will check the contents of the get key to ensure it is an object, which is not a null and is not an array. Once this is confirmed, this object is once again recursively sent to an instance of the same function, only this time we are also passing in the value get or post depending on the top level key being traversed. Once this is done, the newly invoked instance of register routes will again traverse the object that was passed in, which is basically the object that contains our get route handlers. Once again, the if statement will run. However, this time the if condition would not end up in the truthy state, since this time the value of our keys, for instance the root route or the rooms or the chat routes, are not objects. They're functions. Since the if statement requires all three conditions to resolve to true, it fails the check and the else block will be invoked. Once the control reaches here, we know the HTTP method and we will iteratively get access to the route and the route handler functions. So we'll just check to see if the method is get, and if so, we'll invoke router.get, where we'll pass in the key, that is a single forward slash or forward slash rooms or forward slash chat, etc., and the value of the routes object with the given key, which will now resolve to the route handler function, since we are now traversing the second layer within our big routes object. And we have simple key value pairs here denoting the route and its handler function. Similarly, if the method is post, use router.post to register the routes in the same way. Great, so we now have the register routes function. All we'll do now is invoke this function passing in a routes object like so, and once this is done, we'll return the router instance using a simple return statement, because remember, this module is actually an anonymous function. Now back in the root index.js file within our app folder, in the module.exports, instead of pointing to the router instance present here, we'll use a require statement to point to our router module, and we'll also invoke it, so that this statement actually runs the module as a function and ultimately returns the instance of the router with all the routes registered and ready to go. Let's also clean up this file and remove the instance of the router we had placed here. This is obviously not needed anymore. So back in the browser, let's play with the routes and see if it works. And it indeed does as expected. You can see our rooms and chat routes are also working as expected.